Okay, today we finally got there. We are doing multi-step equations. This is with variables on both sides. So all of this isn't something we necessarily had to write, but I wanted to point out something that in 6th grade, we learned how to do regular two-step basic equations. So 3x plus 4 equals 16. We know how to solve that. We just isolate the variable with term, then isolate the variable itself. Easy. 3-step with distribution. This is something we cover in 7th grade. For this one, often with fractions, we would distribute this fraction on the inside. So 1/2 times 6x, 1/2 times 8. And what happens after that first step is the problem looks like a 6th grade problem. That's ultimately our goal. In 7th grade, our goal is to make the harder problems look like the 6th grade problems. And it's no different in 8th grade. In 8th grade, multi-step problems with variables on both sides. Again, this looks complicated, especially seeing as we have x's on both sides. But step 1 is to make sure that the variable is only on one side. So, step 1, after this first step, it's going to look like our 7th grade problem. That's our goal. And then after the 7th grade problem, we make it look like the 6th grade problem. This is all just kind of the same problem, only expanded on. So don't worry when you start seeing these problems. They're not as bad as you might think. And the notes of how to actually solve them are right over here. Step 1, of course, is write the problem down. So 5x minus 1 equals 6x plus 3. Step 2, use addition or subtraction to move the variable to one side. Combine like terms first, if possible. In this case, there are no like terms to put. But here's the thing. There are two ways we could do this. We could either move this 5x, and we can cross that out. Let me go ahead and cross that out. I forgot to do that earlier. But when I cross that out, I'm eliminating it on the left side, and we can solve it this way. So I subtract 5x from both sides. I end up with -1 equals x plus 3. Subtract 3 from both sides, and I get -4 equals x. Or I could subtract the 6x from both sides. That would leave me with -1x minus 1 equals 3. Add 1 to both sides, and I get -1x plus 4. Divide both sides by -1, and I still get x equals -4. It doesn't matter if you are moving the variable from the left side first or the right side. It does not matter. You will get the same answer either way. Another couple examples we had done in class were these two, but I wrote it two different ways. So this problem, we have -3x plus 6 equals -7x plus 34. For this problem, I added the 7x to both sides. I did that first. So I add 7x, I end up with 4x minus 6 equals 34. Add 6 to both sides, and I have 4x equals 40. Divide both sides by 4, and I got x equals 10. That same exact problem could also be done if I went ahead and just subtracted the 3x, or added the 3x to both sides to eliminate it. This gives me a similar setup. We have -6 equals -4x plus 34. I subtract 34 from both sides to get -40 equals -4x. Divide both sides by -4, and I still get +10. Same exact thing for this other problem. We have 3x minus 2 equals -2x minus 47. For this method, I added 2x to both sides. Gave me 5x minus 2 equals -47. Added +2 to both sides to get 45, or -45, which equals 5x. Divide both sides by 5, and I get x equals -9. And once again, I could do the same thing, but by subtracting the 3x. Everything will always come out to be the same. This is what we practice doing. There was a Delta math assignment associated with this, but these were the notes from today. I don't believe anyone was actually, no, I think there were like 3 people absent today. So if you were absent, I hope these notes help you get caught up. If you were not absent, but you just needed a refresher, I hope this helps. And that is it. Good luck.